Okay, a current of 2 ampere was passed through molten lead 2 bromide. A current of 2 ampere was passed through molten lead 2 bromide. A current of 2 bromide. Molten lead 2 bromide. That's PBBRO. Molten lead 2 bromide for 1 hour 30 minutes. Molten lead 2 bromide for 1 hour 30 minutes. Come on. The quantity of electricity in coulombs used is the quantity of electricity used in coulombs. The quantity of electricity used in coulombs is A. Quantity of electricity used in coulombs is A. 2,880 coulombs. A. 2,880 coulombs. B. 1,800 coulombs. B. 10,800 coulombs. C. 180 coulombs. C. 180 coulombs. And then D. 3,600 coulombs. Then we have D. 3,600 coulombs. So try that. Try that very fast in your books and give me the answer.
Calculate coulomb with the current and the time. The number of current that we was 2 ampere, and the time 1 hour 30 minutes. And the time is always calculated in seconds, as is SI unit. So you change it from minutes to seconds and hours to seconds. It's 5,400 seconds. Calculate 1 ampere times seconds, which is the same as 2 ampere times 5,400 seconds, which is 10,800 coulombs.
And the answer is B.
Thank you. Okay, 1 Faraday is equal to A 9,650 coulombs. This is A 9,650 coulombs. B 96,000 coulombs. C 2 mole of electron. 2 mole of electron. And then D. This is half a mole. Half mole. Which one is the answer? B. 96,000.
Don't mind this. They don't laugh with.
Okay, listen to this other one. They say a weak electrolyte is one which A. does not allow electric current to flow through it. B. contains large number of free moving ions. C. contains few number of electrons and is a poor conductor. D. ionized partially and contains free ions.
D.
Contains few number of electrons and is a poor conductor. D says ionized partially and contains free ions.
D.
If something ionized partially, will it contain free ions? You have to contain what? Ions. Listen, they say a weak. Okay, wait. Listen, the question is a weak electrolyte, right? Let's read again. A says does not allow electric current to flow through it. B says contains large number of free moving ions. C says contains few number of what? Electrons and is a poor conductor. D says ionized partially and contains free ions in solution. C says contains few number of electrons and is a poor conductor. Go again. Read again.
The first law states that the mass of an element liberated at the electrode during electrolysis is directly proportional to the quantity of electricity passed.
Okay. Somebody read the second law.
Read a column back.
You want to read Coulomb back? Okay, read back. Read back.
You have to read the column back.
A coulomb is a quantity of electrical charge passing at any point in the circuit in 1 second when the current is 1 ampere.
You say again.
A coulomb is a quantity of electrical charge passing at any point in the circuit in 1 second when the current is 1 ampere.
Beautiful. Somebody read the second law.
Faraday's second law, it states that the mass of different labels during electrolysis by the same The Faraday's second law, it states that the mass of different ions liberated during electrolysis by the same quantity of electricity is directly proportional to its electrochemical. Equivalent or inversely proportional to the charge of the ions of each of the elements
that is, you have the formula there, right?
Yes, sir.
Which says mass proportional to what? Ion cure. You see that?
Yes.
Okay, let me explain that formula there again. Faraday's first law, what did they put there in bracket at the end? Faraday's first law was what? M proportional to what? Cure,
Yes.
right?
Yes.
What did Faraday's second law, what did I say in bracket? M proportional to 1 over what? Cure. Or what?
M proportional to Z.
M proportional to what? Z. Can we explain this mathematically? What does it mean? You can try. You see the same law, but we are just putting in now what? Mathematical form. What is the meaning of proportionality sign? It's something that goes according, right? So if you say M proportional to Q, M stands for what? The mass. Q stands for what? The quantity of what? Charge. In what? Coulombs. So M proportional to Q means mass is proportional to what? The quantity of what? Charge. What does it mean? It means if the mass of two elements is large, what does that mean? The quantity of electricity will also be what? Large. If the quantity of electricity is what? Large, what does it mean? The mass between the two elements is also what? Large. Now for the second law, M, this sign now with 1 day, what does it mean? Inversely proportional. It means now for second law, they are telling us that what? Mass and quantity are what? Inversely proportional. It means if the mass is increasing, quantity will do what? Reduce. If the quantity is reducing, mass will do what? Increase. Or if you want to state it this way for the second law, you just say what? Mass is equal to what? Electrochemical equivalent. Means if the electrochemical equivalent is large, mass will be what? Large. If the mass is small, the equivalent will be what? Small. You see that? So take notes. If a current of 2 ampere is passed through a molten lithium hydride, if a current of 2 ampere is passed through molten lithium hydride, for 20 minutes, is passed through molten lithium hydride for 20 minutes. Put in bracket. Molar volume of gas is 24,000 cm3. Molar volume of gas is 24,000 cm3 at ROTP. Molar volume of gas is 24,000 cm3 at ROTP. Molar volume 24,000 cm3 at ROTP. Calculate 24,000 cm3 at ROTP. ROTP stands for what? Pressure. Calculate number 1, the number of coulombs. Number 2, the Faraday. Please remember in an exam, it's not all the time they will first ask you to calculate what? Quantity in what? Coulombs. Sometimes they can just go straight to calculate what? Faraday. If they just ask you to calculate Faraday, what do you do first? You have to also calculate what? Your coulombs. Because you cannot get Faraday without what? Coulombs. So in the exam, they go straight to Faraday, you should not get confused. It means you have to first start by getting the coulombs. So I say A, get the coulombs, B, calculate the Faraday, and then C, calculate the number of moles of lithium atoms produced. Calculate the number of moles of lithium atoms produced. Calculate the number of moles of lithium atoms produced. Beautiful. Try that one very fast. Try very fast. You have 3 minutes to try that. Calculate the number of moles of lithium atoms produced.
Look for coulombs. So they gave us the amperes. To look for coulombs, they gave us the minutes. So it's 20 minutes. To convert it to seconds, we have to take.
Okay, for those who never got the explanation, this is what we're saying. For you to calculate number of moles, you first of all have to identify the number of what? Electrons, which has been what? Used up. And the number of electrons being used up is the same as what? The number of what? Faraday. We know that the compound we're dealing with is what? Lithium hydride, which is LiH what? 2. And they said to calculate the number of moles of what? Lithium, right? Now if lithium hydride, and that lithium is in what? In group what? Group 1. If an element falls in group 1, means how many ions or valence ions do they have? 1. Right? So lithium ions means the possible ions that are going to be there what? L plus. Now you first of all have to write the equation to show how it was. It gives us what? It is charged. And if it is L plus, is it a cation or an anion? A cation. How do cations dissociate or discharge? By gain of what? Electron. So how many electrons will lithium gain here? 1 electron. So it will be lithium gaining 1 electron to form who? Lithium. And remember, since lithium is a metal, means lithium is what? Solid. You stay, you leave it there. Okay, now you continue from there. What is that, Oscar? Okay. Now, if lithium is gaining how many electrons? 1. Means how many Faraday is it gaining? 1 Faraday. To form how many moles of lithium?
1 mole.
You see here there's 1 mole, right? So lithium is gaining 1 Faraday to form what? 1 mole. So you conclude like this. If what? 1 Faraday of who? Lithium, right? Is needed, right? To form who? 1 mole of who again? Lithium. You see that? Then, since here was in Faraday, right? What was the amount of Faraday you calculated previously? 0.025. Then 0.025 Faraday of lithium, right? Will now give us what? What we want to calculate? Moles, right? So see this side is about moles. So we don't